Hey guys, so here's the notes for 4.6 day 3. We're going to divide and plot complex numbers. Okay, so let's talk about dividing. So we've already talked about adding, subtracting, and multiplying. So the last thing we can do with complex numbers is, of course, dividing. So complex conjugates. Basically what that means is we have a plus bi and a minus bi, meaning that basically the signs in between our a and bi are opposites. And the product of these complex conjugates will be a real number. So you might have seen this when we were just basically multiplying. So in your homework assignments, there might have been 1 or 2 problems where you multiplied and you got like a real number when you did the conjugates. So let's look at this for 4 plus 2i times 4 minus 2i. We're going to see what happens. So notice that in between my real and imaginary part, I have opposite signs. So that's what makes it a conjugate. So I'm going to go ahead and FOIL here. So I'm going to take my 4, multiply by 4, as well as the negative 2i. So I get 16 minus 8i. Now I'm going to do that with the 2i, so 2i times 4, and 2i times negative 2i. So I get, once again, 8i, but this time it's positive, and then I get negative 4i squared. Okay, let's combine our like terms. Now notice in the middle, we have negative 8i and positive 8i. Those just cancel out, right? So now we're left with 16 minus 4. I changed that I squared into a negative 1. Don't forget to do that. And so that gives me 16 plus 4, which gives me 20. So conjugates are very important. Not only do we use it with complex numbers, but we can use it with other things like radicals. And the reason we want to do this is because anytime we have a fraction, we don't like to have like non-real numbers in our, or non-whole numbers in our denominator. So we look at our first example, 7 plus 5i over 1 minus 4i. Notice we have an imaginary, or really a complex answer here in our denominator. We do not like that. Instead, we want a whole number or a real number there. That's it. So what we need to do is we need to multiply the top and bottom by the conjugate. Now, what is that conjugate going to be? Well, that's going to be what we see in the denominator. So here we have 1 minus 4i. What will be the conjugate? Well, the only thing we need to do is switch the sign that's in between the 1 and the 4i. So the conjugate is going to be 1 plus 4i. So that's all you have to do. And we're going to do the same thing to the top, because what you do to the denominator, you got to do to the numerator as well, okay? So from here, we are going to distribute. So this is going back to our multiplication, what you guys did in the 4.6 day 2 notes. So I'm going to take my 7 multiplied by 1 and the 4i. So I get 7 plus 28i. Do the same thing with the 5, multiply by 1 and the 4i. So I get plus 5i plus 20i squared. And now on the bottom, I do the same thing. I do 1 times 1 and 1 times 4i. And then my negative 4i times 1. And then negative 4i times positive. So make sure that gives you negative 16i squared. Okay, we're going to combine like terms and see if we can cancel anything out. So in the top, I'm going to combine my 28i and my 5i. So I get 7 plus 33 there. And then plus 20, change that I squared into a negative, so we have negative 1. Okay, on the bottom, notice that my 4i and negative 4i, they cancel. So that leaves me with 1 minus 16, and we do have to change that I squared into a negative 1. Okay, now, we have 7 plus 33i minus 20, because 20 times negative 1 gives us that. And on the bottom, I have 1 plus 16. Now, I still, once again, combine like terms, so that is going to be the 7 and the negative 20. So when I do that, I get negative 13, and then I have my plus 33i. And that's going to be all over my 17 on the bottom. Okay, now the last thing we need to do is actually separate this So we are in our standard form. So remember we did this when we added and subtracted. We had our a plus bi or a minus bi. We have to do the same thing here. We have to have our a, which is going to be the real part, and then we're going to have our bi, which is the imaginary part. Scoot up just a little bit. There we go. Okay, so how are we going to do this? So we have negative 13. That's going to be over the 17. So I'm going to go ahead and rewrite that here. Now 33 is positive, so I'm just going to go ahead and do a plus. If you rather do plus and then the negative sign whenever it's negative, that might be a good idea. So now we take 33 and put that over our denominator, which is 17. And so when we do that, we have our real part, which is the negative 13 over 17 plus 33i over 17. Now notice that both of these we cannot simplify anymore because there are no numbers that can go into 13 and 17 except for 1. And same thing with 33 and 17. The only number that can go into both of them is 1. So our final answer is negative 13 over 17 plus 33i over 17. Now notice when we did the conjugate in our denominator, we got a real number, 17. Anytime you do this, you should get a real number. If you still have an imaginary or an I in the denominator, then you did not multiply correctly. And that could be either going from your conjugate or how you distribute it. So be careful. Okay, we're going to try another one of those. Okay, I would like you guys to go ahead and pause the video and try this one. Okay, let's see how you did here. So, let's multiply by the conjugate. Okay, the conjugate, remember we look at the denominator. So our conjugate here is going to be 2 minus 6i. And whatever, when I mean conjugate, is that the sign in between the real and imaginary part just changes. So we had an addition, we change it to a subtraction, and that's our conjugate. Okay, let's do our parentheses. So I basically FOIL here. So I do 3 times 2 to give me 6, and 3 times negative 6i to give me negative 18i. Then negative 2i times 2 gives me negative 4i. And negative 2i times negative 6i gives me a plus 12i squared. Okay, on the bottom, I get 2 times 2, which gives me 4, then minus 12i. Then 6i times 2 gives me a positive 12i. Then I get negative 36i squared. Okay, let's combine like terms, eliminate things, and change any I squares into negative 1s. Okay, on the top, I combine my negative 18 and my negative 4 to give me negative 22. Now I have negative 22i. From there, I change my I squared on the 12 to a negative 1. On the bottom, the 12i's cancel because I have a positive and negative. So then I have 4 minus 36, and I change that I squared into a negative 1. Okay, so now I have 6 minus 22i minus 12, and then 4 plus 36. Okay, now once again, combine like terms. I'm going to have to do 6 and then minus negative 12. Or minus 12 there. So that gives me negative 6 minus 22i over, I do 4 plus 36, that gives me 40 here. Okay, now I need to write this in standard form. So I need to kind of do my A part, which is the real, and then I need to do my imaginary. So the real is going to be that negative 6 over 40. So that's going to have that. And then I do have that negative 22i. I'm going to just go ahead and do subtraction. On this one, if you want to do a plus minus, then that's fine as well. Okay? So then I'm going to do negative 22i over 40. Now, once again, notice that I do get a real number in the denominator. So that works, okay? So don't forget, anytime you are doing your conjugate, you should get a real number in the denominator. If you still have I in the denominator, then you did something wrong, okay? Now, just like the last time, we need to see if we can simplify this just a little bit more. So when you think about 6 and 40, is there a number that can go into both of them? Yes, 2. So when we do negative 6 divided by 2, that gives me negative 3. And 40 divided by 2 gives me 20. Now, same thing with the 22 and 40. Is there a number that goes into both of them? Yes. Once again, it's 2. So I'm going to have negative 11i now, and then 40 divided by 2 gives me 20. So my simplified version here, so don't forget you need to simplify your fractions and put it in standard form. So my final answer here is going to be negative 3 over 20 minus 11i over 20. Okay, make sure you watch the second part to this video where we are going to plot complex solutions or complex numbers.